Hello, good morning to all of you. I am Dr. D.D. Sawant from J.A.T Art, Science and Commerce College for Women, Malegaon District, Nashik. I am from Department of Geography. Today's topic that is a sea floor spreading. As a new technology, new discoveries which was put forward by many of the scientists. In the 1950s, new technology advanced to reveal the ocean floor was not flat. As a scientist discovered the mid-Atlantic ridge. The mid-Atlantic ridge is the longest chain of mountains in the world. As far as concerned to the definition, the hypothesis of sea floor spreading is a new development which proves the theory of continental drift. It was put forward jointly by the late Professor Harry H. Hayes of the Princeton University and Robert S. Dice in 1960. The ideas of seafloor spreading is a synthesis of the results obtained by marine geologists and geophysicists like Maurice Ewing and his co-researchers. Hayes and Dice proposed seafloor spreading as the mechanism that builds this mountain chain and drives continental movement. The opinion of Hayes, the submarine mountain ranges called the mid-ocean ridges, were the direct result of upwelling flows of magma from hot areas in the upper mantle and astrosphere and perhaps deeper sources. When mantle convection brings magma up to the crust is fractured and the magma spills out and cools to form new seafloor and hence the buildings, the ridges and spreading laterally. The marine geologists between 1950 and 1960 had been able to establish the following three important facts about the floor of the ocean. Number one, that the crust below the ocean floor was found to be the only 6 to 7 kilometer thick, whereas below the continental surface this thickness was 30 to 40 kilometer. Next one, there is the existence of the mid-Atlantic ridge was known to the geologists and geophysicists, but it was discovered that mid-oceanic ridges were present in all oceans. The ridges are subjected to earthquakes and volcanic eruptions. Third one, that the rocks of the ocean floors now were found to the older than the Cretaceous period, which began about 135 million years ago. On the basis of the above discoveries, Hayes in 1960 proposed that the ocean floor was mobile and hot magma, means the lava, rises up from the earth mantle by convection currents along the middle of mid-oceanic ridges and moves away on either side and finally get lost in the ocean trenches situated along the continental coast. It is through this process of spreading that the ocean floor has been built. In other words, the ocean floor is a relatively young feature of the Earth's surface. It is constantly being regenerated at the mid-ocean ridges and is subject to continuous lateral spreading until it is destroyed in the trench system and becomes reincorporated into the mantle. On the other hand, in spite of the fact that the continent are old and apparently permanent features, they drift apart passively and together on the back of mantle generated convection currents. These facts prove that the continents and ocean basins are in constant motion. So he has put forward the following evidences and arguments in support of his theory of sea floor spreading. That number one, the occurrence of earthquake along the crest of the mid-oceanic ridges. Second one, that the depth of sediments at the crest of the mid-oceanic ridges and the active volcanic islands associated with the crests of the mid-Atlantic ridges are easily explainable in his theory of sea floor spreading. Moreover, the thickness of the sedimentary deposits increase with distance from the ridge. This is inconsistent with sea floor spreading because the more distant parts are older and have had a longer time at their disposal to deposit sediments. Third one, that is the age of the marine sediments above the basaltic layer goes on increasing with distance from the ridge. For example, in the Atlantic Ocean, the age of the main sediments near the ridge was found to be less than 7 million years, while the age of sediments farthest away from the ridge has been calculated to be more than 160 million years. So, there is a reversible in the main magnetic field of the earth known as a magnetic dipole magnetic field. Next, number 5, that the normal and reverse magnetic anomalies are found in alternate manner on either side of the mid-oceanic ridges. Last one, there is a parallelism in the time sequence of paleomagnetic epochs and events calculated for about 4 to 4.5 million years on the basis of magnetism of basaltic rocks or sedimentary rocks. So, as evidences, if you'll see that it may be continuous spreading of sea floor. Basaltic crust is continuously formed along the mid-oceanic ridges. Newly formed basaltic layer is divided into two equal halves and is thus displayed away from the mid-oceanic ridges. Next one, that alternate strips of positive and negative magnetic anomalies are found on either side of the mid-oceanic ridges. Such magnetic anomalies are means the positive and negative are formed because of temporal reversal in the geomagnetic field. The rocks formed during normal geomagnetic field contain positive magnetic anomalies, while the rocks formed during reverse polarity means the reverse geomagnetic field are denoted as a negative magnetic anomalies. Thank you. Thank you very much.